So this is week 5 project, and you should feel free to download the week 5 project.maxpat, which will look basically identical to what you see on the screen here, and follow along as we work through this project. What I decided to do was to take a bit of a stab at assignment 3, which is coming up is due at the end of next week, because assignment 3 is very, very tricky. It is actually a real challenge to be able to simply just play anything on a MIDI keyboard, including chords and polyphony, and to be able to capture everything properly and to be able to play that back, and also to be able to play it back in random order. It's not easy to do. So what I've decided to do is to use the cold data structure that we've come across, we've looked at this week, and to do a modified version of assignment 3 with the restriction that I can only capture melodies. So I'm assuming that I'm not going to play any chords. If I do play chords, I'm going to mess things up. So I've got this touchscreen keyboard in here to try to, restrict myself to just playing a single note at a time. Okay. So first thing we need to decide is I mentioned we're going to use call because that's actually a useful data structure. We need to sort of think about what information we need to store in call so that we can play back essentially a melodic recording, a recording of a melody. And so just sort of thinking through that, we definitely need to know the pitch, we definitely need to know the velocity. And we need to know the note duration, how long the note was played. But we also need to know the delay time between the notes. Right? So, for example, if I play on my keyboard and I play very legato, I can probably get away with just saying, well, the C was this long with this velocity and the D was this long with this velocity, and play them back. But if I play them very staccato, with big durations as gaps between them, then if I just store the duration of the note, then I have a problem, right? Because I do not have all the information I need in order to play back the notes. If I just played them back, I get them following one another immediately, after the short duration. So I need to either store the inter-onset duration, which would be the duration between the time between the start of one note and the start of the next note, or I need to store the gap between the end of one note and the beginning of the next note. Since I'm dealing with melodies, I can get away with just storing the gap between the end of one note and the beginning of the next note. If I were trying to do chords, then I probably need to deal with something a little more complicated, like inter-onset durations and so on. Okay, so let's begin, and make our call. I'm going to call this call pitch collection. And we remember that when we create a call, we need to have a key. We need to put in a list which consists of a key followed by which has a comma followed by the data that we're going to be putting into the call. So this is what I decided we needed. We need the delay before the note starts, the pitch, the velocity, and the note duration. So we need 4 pieces of data. They're all integers because we're going to store our notes in milliseconds. We can't assume that we've got eighth notes and quarter notes here because I can play anything with as much inaccuracy as I want. So all integers. So let's put a pack in here because this is how we're going to build our call. I've put a pack with 5 zeros in it, 5 integers. The first value is going to be the call, or sorry, the key. So that'll be like a 1 comma, and then those values will be the 4 pieces of data that we want to store: the delay before the note starts, the pitch, the velocity, and the note duration. So key, delay, pitch, velocity, duration. Okay. Now, how are we going to set the key? Well, we're going to set the key with a counter. So I'm going to put the counter object in here, going upwards, and I'm going to give it a value of going from 1 to 1,000. I'm going to assume we're not going to have more than 1,000 notes. I'm just going to keep it there for now, but I do know that ultimately it's going to bang here. The last thing we want to do is to bang the first inlet of the pack, and before we do that, we need to make sure that all of these, all that data has been put in there. All right, next, how do we calculate durations? Well, there's an object called a timer that does this for us. And I'm going to put 2 bang buttons in the timer just to show you how timer works. This is the way you start a timer, and this is the way you end a timer. Put an integer box outside it. You'll see that from there to there is 800 milliseconds. From there to there is 2000 milliseconds. So that's about 1 second, and you can see the values coming out of it. Now, if I start it and then just keep clicking this, it will just keep incrementing until I restart the timer. So essentially what I need to do is I need to say, this is the start and this is the stop, and this is the start and this is the stop. Okay? So, and let's put, I'm going to need 2 timers because I need 2 pieces of information here. I'm just going to duplicate that. This is let's call this the note duration. And we're going to call this the delay before a note. Okay. Okay, so how do we get the note duration? When I get my velocity out, I'm going to use a select one to determine, is it a note off, or is it a note on, in which the value will come out of here. All right. So I'm going to use a trigger here for my note on messages, and a trigger over here. This is going to be a trigger BBB for my note on messages. Okay. All right. So I've got those 2 triggers, and I want to determine what is the note duration. Well, that is the distance between the note on and the note off, correct? That is going to give me my note duration. And let's see what it is. So if I play a note here and a short note, you can see that long note, short note. Okay, so that's working. Now the the delay before is the time between the note going off and the next note going down. So we actually reverse that. It'll be the note off here will start the timer, and the note on will end the timer. Now, there's one sort of small problem with this, and that is that the very first note that we play will trigger a very, very long duration, because it will be since the last time we recorded or did anything. So there are ways we can get around that, but just as one way around that is to say, let's look at the incoming value that is coming out of here, and assume that it's going to be between 0 and 10,000 milliseconds. And that if it is not, it will come out. Let's make it a 0, right? So this is a way of basically, you know, if it's the first note, we're going to make it 0. I'm going to make this window bigger, and I'm going to pull this down for now, just temporarily, because I don't really have enough room in this patch for some of the complexity that we're creating here. Okay. So let's see if that works. Let's oh, I just put a you know, a final message box here. What this should mean is that the very first note that I play will be 0. So let's play a note. And then the next note I play, notice there's 3 seconds between those notes. 2 seconds, and let's play some notes that are quite close together. So that is the gap between one note, or the end of one note, and the beginning of the next note. Okay, so we've got those 2 pieces of duration that we need, and we use the timer object to get those. All right, so far so good. Now, the next thing is that for my pack, I have to be a little bit careful that I make sure that I got everything in the right order. You know, I've got to make sure I've got all of my data in all of these inlets before I bang the counter in here. So I'm actually going to be a little bit kind of, I say redundant, but careful. And I'm going to create a bunch of int boxes. Let's make, I'm going to make 4 of these. And remember, int boxes are a way of me storing my data. I'm going to store the 4 pieces of data that I need, and then I'm going to eventually put them into the pack object. Maybe I'll make the pack object a little bit wider like that. All right, this is going in here. This is going in there. This is going in there. And this is going in there. And then the counter is going into there. Okay? So, and I should probably label this just so I know what I'm dealing with. We call it delay. Make it smaller. We don't need it quite that big. Delay, pitch, velocity, and duration. All right? And those are our values that we're pitch, velocity, and duration. Okay. This is just, again, sort of for our own reference there. Okay. Delay, pitch, velocity, and duration. And as I say, you know, that doesn't have to be in that order, but that's what I decided. I decided on my data structure. I know that if I have that data, I can, you know, set up a delay so I wait, and then I play the pitch and the velocity for the duration that's specified. Okay. All right. So let's go on with this. Let's put some of these values in. Well, the pitch. Well, the pitch comes in here, and let's stick it right in there. That's the pitch. The delay before is here. Let's put it in this one. Let's take the note duration and let's put it in this one. And the velocity, you notice I put an I in there. So the note on velocity can come down and it can go in here. Okay, and I'm just going to change the color of those just because I want to. Let's make them blue. Okay. Fine. So those are the values, the final values. I sometimes like to keep things aligned, and sometimes it's actually easier if they're not aligned so you can actually see where they're going. So those are my 4 pieces of data going in that are actually stored in each of those int boxes. And then what I'm going to do with my counter is, first of all, I'm going to see what my counter value is, and then I'm going to use a trigger here, and this trigger is going to look like that. Trigger IBBB, because I want to bang this, bang this, bang this, bang this. Maybe I'll move this back up to where the other ones are. And then not bang this, but actually put this into that's an integer, the actual counter value, put it into the pack. What that does, it makes sure that whatever, the data's all been stored, and then when I hit the counter, the last thing I do is hit the counter, and then all the data gets pushed in, and then the counter value gets pushed in. This is really just a way of being very careful that everything I need has been stored properly and ready to go before I hit the counter. And so the last thing I do when I receive a note off, and this is why we use triggers, the last thing I do is I send a message over here to the counter, and I'm going to change the color of this just because I want purple there. The last thing I do is I send values, I stuff the values into the call. Okay? All right, so now I think that should be working. I don't think I've made any mistakes, but I could be wrong. This is my little record button. And so I've got a record button, a LED, and a select one to see is the record actually happening. And I'm going to trigger a B, a 1, and a clear message. So this means if the recording is happening, it's a 1, it's turned on, then I trigger these 3 things. And the clear is simply going down to the call, because I actually need to clear out all the data that's in the call. A call will take a clear message. The 1 goes into the counter. The middle inlet, this third inlet of the counter, will reset the counter. You can see this, reset counter to number on next clock. That means that when a bang comes in to the counter, it will start again at 1. And then finally, the B. And the B I'm just going to use to, actually, I'm going to go in here and I'm going to restart the timer for the delay before. That means that technically I probably don't need this split, but I'm going to keep it there anyway, because when I start the recording, the first thing it does is it starts that timer. So the duration I have will be between when the record button was pressed and the first note is started. Okay? All right. And let's make these a different color too. We'll make those red. Okay. All right. So there we've got our keyboard. We've got our call. We'll make sure there's nothing in this call. That's what it looks like. It's empty. So what are we expecting when we play notes? We're expecting that we're going to have a 1, comma, and then we're going to have values which represent delay before, pitch, velocity, and duration, semicolon, and then we're going to have 2, comma, the next note with the delay before, the pitch, the velocity, and the note duration. Okay? So let's play it. Let's just play it on. I'll play it on my keyboard. So I'm just going to play fairly staccato notes. I'm gonna forgot to put this. Put it in record. Let's put it in record. Okay, and let's stop the record and go down and open up the call. Okay, so there we see the first note was, that was the duration between the start of the recording and the first note was 1396. The pitch was 72 C, and the velocity was this, and the the duration was 376, and so on. So we there see the C, the D, the E, the F, and the G with delay times about the same and durations about the same. They're about a half a second long each. So it looks correct, okay? And we've got the 1, 2, 3, 4, 5. And here we actually have a 5, the value 5. So we know how many notes were recorded. Now, in fact, it would probably be very wise to store that information somewhere. So I'm going to put it into an int box. And that is because when we want to play things back randomly, or even if we want to play things with a counter in order, we need to know how many notes we actually recorded. Okay? So let's play it. Let's re-record, and we will play something that's got a little bit more sort of just some different rhythms. Well, we'll put it in record. I'll play it on the on-screen keyboard. Okay, so that was 13 notes that we played, and if we open up our call, we'll see there's 13 notes, and you can see that the duration, some of them are very short, some of them are much longer, and the delay times between the note ons and note offs, there's a bit of variety in there. There's a long one here, for example. Okay, so that looks like it's good data. The pitches are certainly correct. The velocities are certainly correct. All right, so that's the first part of the assignment, where we've actually been able to store the data into a data structure that we can use. Okay? Now, the next two parts of the assignment would be, well, how do we play them back in original order, and how can we play them back in standard order? Okay, well, let's put a LED in here, another LED. We're not going to make this fancy. We're not going to deal too much with the user interface at this point. You can deal with all that. This is a play button, and the play button is going to have a select afterwards. It's going to be, is it on or not? I always need to know that, because I'm going to do different things whether I'm stopping the playback or starting the playback. And let's just do a I don't know, let's just deal with the starting the play. So let's put a trigger in here. And this trigger is going to have a bunch of different things. Some of this I'll use, some of it I won't. One of the first things I want to do, I'm going to, actually I'll just leave that. Actually, I'll just get rid of this for now. Just the very first thing I do, remember triggers go from right to left, is I want to go down here and I want to bang this value out. Excuse me, because that's the counter number, and I need to know how many notes that I actually recorded. Right, so I'm going to use a counter, and by default I'm going to say 1 to 1,000. But I'm going to take this value and I'm going to take it over here and I'm going to put it into the maximum, right? So, excuse me, if the counter and recording was 13, then the maximum value that I'm going to record is going to be 13. Okay, so I've got my counter here. And I'm going to use the 1 to set the start of the counter, because I might have stopped the counter. So I've set my counter to 1. And then I need to have a bang to start my counter going. So I'm going to, I'll put a bang button here just so I've got some kind of graphical representation of that. So those are the things that I need to do when I'm going to start playing. I need to go and figure out how many notes there were. that I need to set my counter back to 1. I need to start the counter going. And the next thing I need to do is I need to go into my call. Now, because I have named this call pitch call, I can simply make another copy of it. And if I double click on this, the data that I recorded into will also be there. Okay, so this is basically referencing the same data. I don't need to go over to the other one. I can just make another one that has the same name. And then I need to unpack all of this. Now, how many values are there coming out? There will be 4, because we're putting, the counter is giving us the key, and the remainder, the data that comes out of the call, will be the 4 values: the delay time, the pitch, the velocity, and the duration. And I'm going to do something that was similar to what I did before, because I need to control when I actually use this data. So I'm going to pull it all out, and I'm going to store it temporarily in these int 0 boxes. So remember, int can store data. So I'm going to store everything in here, and I'm going to line it up so it's nice. There we go. Those are my 4 values that came out of that. Well, I'm actually going to store the last 3, because the first one that I'm going to use is the delay time. And I'm going to do this. The trigger BI is a trigger combination you use a lot, where you've got a value coming in. And what I need to do with this is I need to create a delay, because I don't want to play right away. I want to use a delay. If I can type delay, and I'm just going to put 0 in because I need it. What I need to do with this trigger is I need to pass the value of the delay into the right, and then put the actual delay bang in the left. All right, does that make sense? Because what's coming out of here is the first value. Let's say it's 1024. Then I want to basically say, okay, put 1024 in here, and then bang it so that it waits. And then what I need to do is to send, when the delay time is fulfilled, then I need to bang each of these objects to output the values that I've stored in them. Okay, in here, and in here. Guess I can go this direction. Let's make those a different color too. Or that's too close to. There's an ugly color. That's good. All right. So what will now happen is that I will get my make note object. I can put some arbitrary values into it, and then a note out object. Probably should supply a channel. Try that again. Note out 1. And let's put those values in. That was my duration. That was my velocity. And that was my pitch. Right? Those are the values that came out. So, and you can see why I'm using triggers. I hope you can see why I'm using triggers, because if I've got to make sure that things are done in the right order, and if I don't do that, I run the risk. For example, if I just put these values straight into the make note, then it plays the note, and the delay doesn't happen. So what I need to do is to at least delay the pitch. Now, I could have put the velocity and the duration values in directly and just hold off on the pitch, and then after the delay, pass the pitch. That would have worked. All right. And So what this is going to do is this is going to play over and over again until I turn it off. That's fine. I could, what I had originally put the extra trigger in here is because I was thinking of a gate and being able to sort of turn off the gate when I wanted it to stop. Let's say when I got to the end of the counter got to the end of the first time through, it would stop. All right, so let's all hold our breath and see if this actually works. So if I play this now, I think I've done everything, and we should hear. And I didn't hear it all. Let's try it again. Oh, we're missing something. Yes, because we're only getting one value, right? So we need to bang the next value. Yeah. Right? Okay. We're not done yet. So that bangs the first value, but then after that value is done, we need to play the next note. Okay? So when does that happen? Well, that happens after the delay of the duration of the note, right? So if we, which is also a good reason why we've separated this out. So we need another delay object. And we need a trigger here, which is going to be, well, let's make it B, I. I'm going to disconnect that. And this is going over here. So that is the duration of the note. And we're going to do a couple things with that. We're going to, first of all, put it in here. And then we're going to put the actual duration in here. We'll put a default value in there. That's sort of good practice to do that. And then bang this. And then this goes up. And this goes into the counter. Okay, we needed a loop. All right, and now this is getting complicated. I told you it was complicated, and this is actually kind of an easier version. All right, so let's go through what's happening. The counter gets banged once. It extracts the data from the call. The pitch, let's do it in the proper order. The duration of the note goes in here. The velocity goes in here. The pitch goes in here. And the delay, the before delay, now there's the duration before we start the note, goes in here, which triggers a delay. So we wait a little bit of time. And then once that delay happens, we send a trigger to all of these so that the data goes in. But in addition to having, when we send the bang over to the note duration, it goes into another trigger, and that trigger goes in here, but then it also sends another delay, which is the delay of the note duration, and after the note duration is done, we bang this again. Okay, so let's see if this works. Okay, that worked. And it's going to keep going on until I stop it. And in fact, I don't have any way of stopping it other than to disconnect this. Okay? So the last thing I'm going to do is put the gate in. Actually, I don't need the one there, really. It's just going to be a straight gate. and I'm going to put a toggle box above the gate. And then I'm going to do what I did before. I'm going to add that 1 in there to control the gate, and I'm going to put that into the gate, and that delay value, instead of going straight into the counter, is going to go through a gate and then go into the counter, right? So that I can turn off the gate. Now I can either just make it manual to turn this off, or I could basically take the what do you call that, the carry count, and I could, you know, when I reach the end of my counter, then I could close the gate. So this would sort of automated. This will only play through once. Okay, so now let's play it. And it stopped. The gate got turned off, right? And probably I'd also want to turn that off automatically as well. So I'm not going to do everything. All right, so this is the guts of a just playing back in normal order. What would you do to play back in random order? Well, you wouldn't use a counter, but you'd use a random object. And the random object would basically have the value from here placed in it. And so it would be random, this value. And then you would always add 1 to the output of the random, because your index into the call is not 0 through 12, it's 1 through 13, or 1 through however many notes you have. So put the value into the random, but then make sure that you add 1 to the random, and do a similar thing. All of this would be basically the same. The only thing that would really be changed is this would be random, and it would end up having 13, and this would be again the call, and then you'd unpack it and do all the delay and all the playback stuff. So there. And the delay would then go back and bang the random again. And so rather than counting through, you get random numbers. So basically 90% of the random playback is done. Okay, now this patch has got a lot of cleaning up to do. You certainly could encapsulate a lot of this. The whole record process could be put into a sub patch. The playback of each one could be put into a sub patch. I haven't done that at this point because I really wanted to, go through it sort of methodically and excuse me, make sure that it all made sense to you. It's a complex patch in the sense of the way in which it's manipulating data and storing data. We're being very careful about ensuring that things happen in the right time, in the right order. If you don't do that, then you're going to have problems. You really have to be careful to think, okay, this event there are 4 things that are happening. Which needs to happen first? Which needs to happen last? If we ignore this, for example, and this, and we don't ensure that the last thing that gets done is the counter, which causes everything, all the stored data, to be packed, then we probably do not get the right data, because we can't guarantee that the note duration has been calculated already before we've banged the counter in. So this is if we didn't do this and we moved the counter, and the counter was here, it would happen before this timer would happen, right? Because this is to the right of the timer. So triggers are really important here. I'm not going to spend any more time on this. There's lots of things I would do to clean this up, but this is functionally, I would say 90% of the one version of the assignment 6 or assignment 3 that's due on at the end of week 6. Okay, so you are not going to get all of this. If you want to build it as I've done it, please go ahead and do it. You'll have the starter. It turns out that I didn't need this in the end. I might be sending it somewhere just to display the, let me put that in, just to display the pitches that have been played. Or maybe that's going into a note slider in my interface. So I meant to do an N slider. Oh, keep on. N slider. Can't type any longer. Like that. Right? So that as I'm playing notes in record mode. So even something like that, which is basically a fast rundown, all of that data should have been recorded properly. And if I look at this, I see, yeah, with basically no delay times. And if I play this, okay, so it's there. All right, good luck with this. I know this is a long video. It was a complex project. And as I said, if you complete this and do something very similar, you will do okay with assignment 6. Because I understand this is complicated. If you want to look at the borax tutorial, which is you can download, or if you want to use a combination of the sequencer object and QLists or something else, you can also look at that. But this is a solution to assignment 6. Thank you.